Hello, everyone. My name is Bo. I work for Brightcove. And today I'm going to present my work on the performance of low latency HOS and low latency dash streaming player. So first, what is low latency live streaming? So there are currently two competing technologies in this domain, the low latency HOS and low latency dash or CMAF. The design principle of low latency live streaming is similar for these two technologies. On the server side, the encoder and the CDN is to encode and deliver video in smaller chunks, such as 1 second chunk, without waiting for an entire segment to be generated. So on the client side, the client needs to request a segment as soon as the first chunk becomes available. And in this way, the desired end-to-end latency can be reduced to be less than 5 seconds. The objective of our work is to evaluate the performance of existing low latency HOS and low latency dash players. And we evaluate the players using the following performance metrics, including the average latency, stream bitrate, video resolution, and we also have frequency of bitrate switches, frequency of rebuffering events, the total amount of data downloaded, the number of media objects downloaded, and the variation of playback speed. And this is how we set up our experiment. So we have two test streams, and we set up the stream using the by looping the video file called Big Buck Bunny. So we repeatedly over 10 minutes session, and we encode the Big Buck Bunny into 3 renditions. The lowest bitrate rendition has a video resolution of 320 by 180 and a bitrate of 279 kbps. And the highest bitrate rendition has a video resolution of 768 by 432 and bitrate is 1253. And we set up the low latency HOS stream using FFmpeg and Apple's HOS reference tools. And we set up our low latency dash stream using FFmpeg and Node.jpg dash. We also use fragmented MP4 as the container format for encapsulating the segments. And the segment duration is 4 seconds. Chunk duration is 1 second. So each segment has 4 chunks given this setting. And this is actually the default setting used by Apple's HOS reference tools. So we basically use the same setting. And as we said, we play the video file Big Buck Bunny for over a period of 10 minutes, so 600 seconds. So ideally there should be, each player should download 150 segments, 600 divided by 4 seconds, or equivalently 600 chunks, 600 divided by 1. And we evaluated 3 HOS players in their low latency mode, AV player running on iOS 14, HOS.js and Shaka player. And we also evaluate 2 dash players, the original dash.js and 2 dash.js variants. And these are, they are called LOL and L2O. And these 2 variants actually contain propose 2 machine learning based algorithm, bitrate adaptation algorithms, and they optimized the player streaming performance targeting a low latency playback mode. And also we instrument all the players to log and send back the performance metrics to a backend logging server. And we also use the servers, web server, origin servers, access log for collecting the performance metrics. And this is our low latency streaming server setup, the workflow. So for HOS, we have FFmpeg generating multiple bitrate input video stream and send it over to media stream packager, which is a part of the HOS reference tool. And then the media stream packager will generate the chunked low latency HOS stream and push it to Nginx, which is the streaming server, and the player can be any player, AV player running on iOS, or the web players like HOS.js or Shaka player. They request segments and manifest from the Nginx server, and Nginx will read the segments chunk by chunk and then send it over to the clients. And for Dash, the setup is similar. The encoder generates the input video stream, send it to FFmpeg. FFmpeg will repackage and generate the chunked Dash stream in low latency mode and send it to Node JPEG Dash, which is a JPEG software written in Node.js. And then the client send requests for segments, and the Node JPEG Dash will also read the segments chunk by chunk and send it to the client. So all the players runs in an emulated network environment. It runs in a network container, which is limits the outgoing and incoming network bandwidth, so that all the players download the segments at a limited bandwidth. And this is how we emulate the network. We run all the players on top of two real-world emulated networks using a network emulator called Mahi. And we use two network traces, T-Mobile 4G LTE network and Verizon 4G LTE network. And this diagram below shows the variation of network bandwidth over time, over 10 minutes session. And as we can see, the bandwidth is low, and the average bandwidth is about 1 to 1.6 megabits per second for both networks. And we can also see that the bandwidth fluctuates significantly over time. And next, we're going to show the results of when using the Verizon 4G LTE network. We first look at the stream bitrate. For HOS, AV player is the best player, and Shaka player is also good. They maintain a high bitrate for most of the time during the 10-minute session, but HOS.js was struggling at lower bitrate for sometimes in the middle of the session. And for Dash, the original Dash.js and Dash.js plus L2all, they maintain a good bandwidth, good bitrate throughout the session, while the LOL variant was playing at lower bitrate. Next is the video height, video resolution. So the resolution is proportional to the video bitrate. So the pattern of the plots are very much similar for video height and stream bitrate. And next, we look at the streaming latency. For HOS, the HOS.js has the lowest average streaming latency. However, as we can see, even though its average latency is low, as we can see, there were several major spikes in the middle of this the playback. So the variation of the latency is very high. But for Shaka player, even though the average latency is slightly higher than HOS.js, its fluctuation, its variation is much lower. It's almost constant at about 7 to 8 seconds. And AV player also has a more stable latency, but slightly higher than the two. And for Dash, for some reason, the Dash players has a lower latency than the HOS players. So the original Dash.js was slightly higher, has slightly higher latency than the other variants, because the two other variants seem to optimize just for latency, looks like. And it favors latency other than other performance metrics. And but there were also major spikes in the middle of the session. So next we look at the playback speed. For HOS.js, because the latency, streaming latency fluctuates significantly, and the player has to adjust the playback speed accordingly throughout the session. So that's why we see a high variation of the playback speed for HOS.js, the blue lines, and while other players they always stuck to the stream's native speed. 1.0 is the native speed throughout the session, which is good. And next we look at the statistics. So latency wise, the Dash player seems to be able to maintain lower latencies than HOS players. So LOL and L2R has lower 3.2 and 3.9 seconds, while Dash.js also has 3.771. So latency is much lower for Dash than HOS while playing at low latency mode. And for HOS, the players requested a lot of send a lot of GET requests to the streaming server, posting a large large workload on the origin server. And this is because the low latency HOS players has to request each chunk individually from a segment, but HOS the players only request whole segments, and the server will push the chunk one by one to the player. So HOS issues more GET requests. And for number of rebuffering events, the 2-JS variant has much more rebuffering than all other players. And this is because these two players play too close to the live edge, so that it's more prone to the network stability and rebuffering. So low latency sometimes comes at a price of more rebuffering. So I'm going to skip the result for T-Mobile 4G LTE network. So I'm going to show a demo. I'll switch screen, share my, here it is. Okay, so so this is my experiment setup. First, I'll start the media. I'll start the media stream segmenter, which is HOS reference tools provided by Apple, and then this media stream listens on this port, listens for incoming stream from FFmpeg, and then I'll generate the FFmpeg source stream. Okay, so media stream segmenter is receiving the data and writing the segments onto disk. And next, I'm going to share another window. So this is my origin server setup. Everything is wrapped up in a Docker container. So I'm going to start the container, and then I'm going to log into it. Log into the container, and then I'll start the Maki container for network emulation. Logging as non-root. Start Maki, and then I'll start a PHP FPM, which is a PHP daemon, and then I'll start the Nginx, which is the origin server. Okay, so everything is set up. And next, I'm going to switching to the player. Okay, so this is the player. I'm going to reload the player and play it. And it plays. And here's the timestamp of my local time. And I can't show two windows at the same time, but as I can see, the difference of the timestamp on the video is about 7 seconds from the current local time, and 7 seconds is considered low latency. It was slightly higher than 5 seconds, and this is because I'm running the network emulator. The bandwidth is low and fluctuating, and also there was a latency. So this is why the latency is high. Okay, so that's all for my presentation. Yeah, I hope you guys likes my presentation. So that's the end. Okay, thank you very much for listening. Bye-bye.